Engineering is one of the disciplines that can change the world. Engineers make things that have tangible impact to the environment and to the society.
Diverse minds are what gives us different approaches to problem solving. And I think some of the best solutions that we get come from different perspectives on the problem.
As engineers, we have very complex challenges to solve for society, and the only way we can come up with appropriate solutions is if we really do consider all people within our society.
Innovation is really our lifeblood. We're almost not doing engineering unless we're innovating.
And what we're really talking about is building the future. It's not just about solving today's problems, but about dreaming up the world of tomorrow.
Good evening and a very warm welcome to the launch of the UNSW Institute for Industrial Decarbonisation. I'm Julian Epps, Dean of Engineering. I'd like to begin by acknowledging the traditional custodians of the land we're meeting on, the Gadigal. Pay my respects to elders past and present, and extend that respect to other Aboriginal and Torres Strait Islanders who are present here today. Indigenous knowledge has enabled people to live here sustainably for tens of thousands of years. They make Australia unique in the world, and they have the potential to transform some of our current approaches to innovation. From reading some media reports, it would be easy to believe that decarbonisation is mostly about renewable energy generation. And UNSW has made great strides in this, inventing the PERC solar cell that now represents more than 90% of the global production of solar energy. Much of our current activity at UNSW is focused on the energy transition and recycling. However, as we'll hear tonight, and I was amazed when I first learned this, decarbonisation is much, much broader and has some fascinating practical challenges that span almost all of engineering, let alone many other disciplines as well. The Institute was created to harness UNSW's leading research to tackle quite a range of different areas. For example, clean tech for creating metals, plastics, building materials, and industrial chemicals, an enormous area. One example is blast furnace innovations for sustainable low-carbon iron making. Another example is converting waste plastic into an aqueous dispersion of plastic polymer nanoparticles for recycling. Other areas include innovation across mining systems linked to sustainable production of strategic metals. Planning and design solutions for cities and infrastructure. Translation initiatives that bring new tech to market faster. Business insights and other information to guide investment decision-making. Portfolio approaches to decarbonisation that are tailored to the needs of sectors. Approaches that integrate energy and other clean technologies within operational, design, planning, and economic development processes. I really like the name industrial decarbonisation. Climate change is a problem. Net zero is a target. Decarbonise is a verb, and it's what we'll all practically be doing on our path to reducing carbon pollution. Industrial refers to the scale of what we're doing. Entire industries, all industries are decarbonising. As we'll hear, the Institute is similarly one of the largest scale endeavours within UNSW, with around approximately $600 million of industry projects that are currently already underway. And of course, as a future opportunity, a future industry for Australia, decarbonisation represents an enormous opportunity, and it's one that we can build together. I'm delighted to now introduce UNSW's Vice-Chancellor and President, Professor Attila Brungs, to give the welcome address.
Thank you, kindly, Julian. And a very warm welcome to you all. I really appreciate you all being here today because today it really is an exciting afternoon for us. In particular, I would like to acknowledge David Eyre. Where was he? I was talking a second ago. David, where is David? There you go, mate. Okay, the CEO of the Institute, again, for your wonderful work. Romilly Madew, where is Romilly? Who has not only doing this for us this evening, but I think this is about the fourth UNSW event that she's contributed to in the last little while. So thank you very much for your ongoing support. Grant King, of course, the chair, as Grant's just there, who's the chair of the UNSW's Dean's Advisory Committee. The Dean, who does such an extraordinary job in leading through initiatives like this. And I'd also like to acknowledge the former Dean, Stephen Foster, who was one of the first people to really drive this idea. And lastly, but by no means least, acknowledge the talent and the incredibly collaborative and optimistic attitude of so many UNSW research leaders who contributed to both establishing this and making sure this is one of the biggest and most important initiatives right across the university. It is, as I said, wonderful to see such a great turnout today, all united by our shared dedication to achieving a sustainable future for our planet. As Julian said, ensuring the decarbonisation of our economy from one reliant on fossil fuels to one driven by clean, low-emissions technology isn't just about the energy itself, it's about a whole myriad of other pieces. And it is perhaps the most important, not just technological or even technical, but social challenge of our time. Because no matter how good our technology is, no matter how good our solutions may be, things that change the nation on a global scale are all about people. And again, that's something else that this institute recognises deeply. So it's not just, as Julian said, about green energy. It's about tackling emissions from all the sectors. It's about production of materials such as steel, industrial chemicals, plastics, cement. But importantly then, it's about planning, designing, doing things differently that reduce carbon embodied in buildings and infrastructure. And once again, that all comes down to people, how people work together and how people do things. It's about addressing pollution at the source. And in the end, it's about creating an operating environment that will support growth in Australia and make sure the world is one that is sustainable. Now, this Institute for Industrial Decarbonisation, and like Julian, I love the name, it is, as you can hear, a pan-university institute, which focuses on assembling the technology, the economic, the policy innovations, the people's perspectives, the social cohesion needed to enable a green industry development. If we think about what's happening in the world today, there's a whole lot of, in certain countries such as Australia and others, where we are renewing our infrastructure. So the Institute is very important. Similarly, we have partnerships with nations like India, who are about to invest in a massive amount of infrastructure right across their economy. Now, if you don't design the carbon embedded in the first place, you don't have to get rid of it 20 years later. So how we think about challenges like this are one of the critical things, again, that this institute can do. And it can do this because this institute draws upon UNSW's deep credentials in sustainability, renewables, clean energy, but of course leverages the transdisciplinary expertise that we have right across all faculties of the university. It's been designed to be a one-stop shop to help companies, governments, agencies, communities really achieve effective portfolio solutions. So the teams are drawn from business, engineering, science, design, planning, policy, and social fields. By utilising all of this expertise, the Institute significantly increases our chance of tackling these challenges and really making a long-lasting difference. In just a moment, David will provide more detail about the excellent work that the Institute is doing and its comprehensive programs. But I'd like to close with a couple of things. First of all, for me as Vice-Chancellor, this Institute is an exemplar of UNSW for two reasons. One, its deep commitment to having positive societal impact in Australia and around the world. And along with that, holding itself to account that societal impact isn't just nice words, lofty aspirations, lovely things to think about doing, but really concretely achieving them. And the second thing, again as an exemplar, it brings together not just people right across the university, but right across the university, across government, across community groups, and across nations, because we all have to work together if we really want to be significant in this. The challenges are huge, but the opportunities are also immense. And once again, I'd like to congratulate the team and thank everybody here who is partnering with us to make sure that we really do achieve all the aspirations of the quite audacious plans within this institute. Once again, thank you very much and a very warm welcome to you all.
Thank you very much, Attila. It's now my pleasure to introduce David Eyre, who is the CEO of the UNSW Institute for Industrial Decarbonisation. Previously, through a 30-year career spanning research, industry and government sectors, David led programs in the areas of renewable energy, water efficiency, supply chain optimisation, natural resource regulation, integrated planning and environmental risk management. Prior to joining UNSW, he was CEO of the Future Food Systems Cooperative Research Centre, a national initiative working to optimise the nutritional productivity and environmental performance of Australia's food and agribusiness sectors. His academic background is in complex systems and analytical approaches to sustainable development. Board and advisory roles have included non-executive director, Land and Water Australia, the New South Wales Natural Resources Advisory Council, Cisco Innovation Central, Sydney, and Commonwealth industry working groups in the climate, carbon accounting, big data, and natural resource domains. Thank you, David.
Hello, everyone. I've got some acknowledgements to start with as well. First, I want to acknowledge this incredible university. I don't think there's any university on the planet that is doing so much for sustainability and brings so much capability to the challenge. But there's some people too. Julian Epps, who you just met before, our Vice-Chancellor, Prof. Steve Foster, Ian Gibson, our Industry Advisory Committee, including Romilly Madew, who you'll hear from in a moment, and on the panel. Madew Deb and her team who put this wonderful event together, and our brilliant research leaders, drawn from all faculties. Reducing society's dependence on fossil resources requires deep change in technology, infrastructure, urban design, and the structure of economies. It's a huge call to step away from industrial systems that are reliable, cost-effective, and have been perfected over centuries. But it has to be done. You can call it Industrial Revolution 2.0. Historians will sort that out. But any way you look at it, it's a profoundly complex process involving step changes and potentially a lot of economic risk, some nasty shocks. Those of you working in the field, and I've seen many familiar faces tonight, know just how complex and how risky decarbonisation can be if we don't get the process right. We need to decarbonise, but we mustn't break the economy or the social contract in the process. The Commonwealth's Future Made in Australia vision is to link decarbonisation to green manufacturing and building green export industries. But how realistically do we get there? The Institute's 6 programs are designed to support companies in this decarbonisation journey, not just the invention of clean technology, but adoption at scale. Whether a company is an SME or among the biggest in the world, like our partners in the mining sector, all of them are seeking portfolio solutions that are viable in the context of their supply chains and their end markets. As Julian mentioned, UNSW is currently leading a massive amount of decarbonisation work, around 600 million. Few, if any, universities globally are doing more than that. The Institute's been created to bring synergies and identify gaps in research, form new high-impact projects and provide a coherent one-stop shop for industry engagement. The public discourse is currently focused on energy, but decarbonisation is more complicated. Switching to renewable energy is necessary, but it's not sufficient. I was talking to a mining executive recently who told me her company invested hundreds of millions in electrifying their giant trucks. Then someone on the team asked, but do we actually need all these trucks? They concluded that overhead solutions, a bit like ski lifts, controlled by smart automation, would provide better bang for buck at many sites. It would increase energy efficiency, but it would also deliver savings in time and cost, less need for service roads, and it'd be safer for their staff. My point is that thinking outside the box and drawing on advances across many technologies provides the best net outcome. Industrial decarbonisation is always going to be a portfolio approach, guided by economic considerations. Our programs are focused on opportunities in hard-to-decarbonise sectors. Low-carbon materials is focused on clean production of essential industrial products, green versions of heavy industry. Examples include smelting metal ores using green hydrogen, using green ammonia as a precursor for fertiliser. Our ag sector would love to have green fertiliser. Replacing petroleum feedstocks in plastic manufacture. Imagine if we could crack that. Imagine a world where single-use plastics didn't use hydrocarbons and were actually biodegradable. Put enough money to that research, we can crack it. And of course, low-carbon cements, one of the most used commodities on the planet. We take it for granted, a massive source of carbon emissions globally. We can actually produce that material. Getting it to market is a whole other challenge. Sustainable Mining Systems Program covers solutions that reduce emissions from resource extraction. Many different kinds of technology are required in the mining sector. But linking that to green metal production is the real key. We have abundant mineral resources. Imagine if we could start valuating more of those resources prior to export. We've got the technology to smelt ores in the lab. How do we actually get brand new facilities in Australia where we can either early stage process or even complete certain specialist metals? That is a pathway for increased prosperity for the Australian economy. The Future Infrastructure Program is about integrated approaches to water, transport and energy services. Historically, planning for infrastructure is not well integrated, nor is it optimised for green industry. If we're going to have green industry in Australia, we need to share infrastructure for water, energy and transport. We need to think very systematically about how we put that together so that different companies can leverage that infrastructure. Net Zero Cities program addresses the engineering, architectural and planning aspects of making cities more sustainable and resilient. This includes adapting design and building codes to use the low carbon steel, cement and composites that we're inventing. Research includes efficiencies from breakthroughs in computational design and smart modular prefabrication. This sort of thing is happening globally. How do we bring it into Australia and make that the future of our building and construction sector? We've got terrific people on our industry advisory committee who are real experts in this field, and they really understand how hard it is to get these technologies into our market. Our aim is to help make that happen. Then there's analytics, carbon accounting and AI, which is actually one of the strengths of UNSW. We've got terrific modelers across economics, business, techno-economics, urban planning, carbon accounting. Can we put that expertise together to provide really strong guidance to our industry partners? No one is currently really doing that. There are islands of analysis in that space, but putting it together in a way that is independent, trusted and continuously improves is a huge contribution that UNSW can make to the decarbonisation challenge in Australia. Then finally, the sixth program is Green Industry Development Strategy. Now, this is really designed to support our peak processes that people like Attila deliver, and it's wider than decarbonisation. It's about sustainability, industry development strategy, future workforce, and overall how universities like UNSW can help Australia become more prosperous and resilient, and how we deal with big shifts in the global economy so that we don't lose market share as the economy becomes more green. We've got some terrific people from business, from many faculties involved in that stream. It's not hardcore technical research, but it's still very important to what we're trying to do here. In conclusion, industrial decarbonisation is a challenge of historic scale. It's a mega project that's motivating professionals and young people entering the workforce across all disciplines, all sectors. It's difficult, but there are many reasons to be optimistic. Rapid advances in science and technology are making it possible to provide essential goods and services in more sustainable ways. Australia has opportunities in the emerging global green economy due to its abundance of copper and rare earths and other minerals, and our ability to create renewable energy. We put those two things together, potentially there's a very interesting future for Australia. Competitive niches and specific development pathways, however, are not yet obvious. Which metal? Which metals do we want to develop? Maybe it's not iron ore in future, or it could be magnetite. Maybe it's selenium. We need to do the analysis to figure out which minerals we can most competitively develop and where to put those facilities geographically and how we align the infrastructure. How do we deal with the structural adjustment issues surrounding workforce, which is where the macroeconomic piece becomes so important. So, timing is absolutely critical. Fundamental changes to industrial facilities and processes and how we design and operate our cities are required. This means committing to technological planning and economic choices decades ahead of results, and frankly, without a great deal of certainty. You know, everyone needs to take a deep breath and just do it, get on with it. Universities like UNSW have a key role, not just in inventing new technologies, but also in supporting change processes. Anyway, I hope you leave this event excited about what is possible and that you share your thoughts with your colleagues. Thank you.
Thank you very much, David. So much exciting work ahead of us. And to discuss this, we've got, in more detail, we've got an excellent panel who I now have the privilege to introduce. So you've met David Eyre already. I'm now pleased to introduce Romilly Madew, who is the CEO of Engineers Australia. Previously, Romilly was CEO Infrastructure Australia. Before joining Infrastructure Australia, Romilly was CEO of Green Building Council of Australia for 13 years. In acknowledgement of her contribution to Australia's sustainable building movement, Romilly was awarded an Order of Australia in 2019. In her capacity as CEO of Engineers Australia, she sits on the STEM Champions of Change Committee. She's also currently a member of the Australian Academy of Technology and Engineering, Infrastructure Forum, Director Placemaking New South Wales Board, member Infrastructure Net Zero Steering Committee, Chair of the UNSW Institute for Industrial Decarbonisation, Federal Government appointee on the Circular Economy Ministerial Advisory Group and G20 Empower, member Industry Skills Australia's IAC. I'm getting a bit of a wind-up here, but suffice to say that Romilly is involved in a huge range of exciting activities, all directly related to decarbonisation, and is also an active surf lifesaver. I'm sure you don't mind me mentioning that, Romilly, on Sydney's northern beaches. Let me now introduce Grant King, who is the chairman. Yes, please come on up, Romilly. Grant King is the chairman of HSBC Australia, Sydney Water and Transgrid. He is also chairman of North Harbour Clean Energy in Arventa and runs his own advisory business specialising in energy markets, climate and technology. He also holds a position as Professor of Energy Engineering, chairs the Engineering Deans Advisory Council, which I'm personally very grateful for, and the Energy Institute, and a board member of UNSW's Trailblazer, A-Trace. That's all just at UNSW. He's also the director of O'Connell Street Associates and was the former chair of the Climate Change Authority, Green Collar, CWP Renewables, Contact Energy, Oil Company of Australia, and a former director of BHP. And Grant also has extensive experience, but please do come up, Grant, yes, in the Australian energy industry. He's giving me the wind up as well. We only got part way through, Grant. Grant's also involved in a number of community and philanthropic activities, which is wonderful too. So with that wind up, maybe I'll move on to Scientia Professor Rose Amal. Rose Amal is a Scientia Professor at the UNSW School of Chemical Engineering, where she's co-director of the ARC Training Centre for the Global Hydrogen Economy. Lead of the Power Fuels, including hydrogen, network under the New South Wales Decarbonisation Innovation Hub, and Deputy Director for the ARC Centre of Excellence for Carbon Science and Innovation. She's a passionate chemical engineer, I can vouch for that personally, and is recognised as a pioneer and leading authority in the fields of fine particle technology, photocatalysis, and functional nanomaterials. Her research focuses on designing nanomaterials for solar and chemical energy conversion applications and energy systems for solar-induced processes using the sun's energy to generate clean and sustainable fuel. So with that, over to you, David.
Thank you very much, Julian. You might have noticed there's a chair missing. Professor Richard Holden unfortunately came down with COVID yesterday, so we don't have our economist on the panel, which I think is a real shame. But we've got so much expertise here that I think we can deal with that gap.
We'll wing it.
And you'll all have more chances to talk. So a very large number of terrific, well-informed questions came in via the registration process. Over the next 50 minutes, we'll try to do those justice. And you can also submit questions via the QR code and an app if you feel inclined to do so. We won't do the usual Q&A session at the end. So if you have a burning question, please enter it via the app. And of course, there's great opportunity to network and talk after the panel finishes. So getting on with it, I'll start with you, Grant. As chair of the Climate Authority, you've just completed the 2024 Pathway Review Report. It's not released yet, but could you share some high-level findings? How's Australia tracking, and what are the biggest risks and opportunities?
Sure. Look, firstly, congratulations for the establishment of the Hub, and thank you for the opportunity to be part of the panel here today. Certainly one of my last acts as Chair of the Authority was to give the Minister, Chris Bowen, that report, which was about an 18-month piece of work on what was called Sectoral Pathways to Net Zero by 2050. I'll give a very quick wrap. The report's not in the public domain, but it's not actually advising the government on interest rates or anything particularly sensitive. And a lot of it's driven by knowledge that most people would have, perhaps not coalesced in the way it's been done in the report. So I'll touch on some of those. As always, I like to start with some numbers because I think numbers always help inform a discussion. So the task, currently the national inventory is around 430 million tonnes or thereabouts of carbon a year. So net zero by 2050 means losing 430 million tonnes in 25 years. If you break it down into the sectors, the energy sector, generation, etc., is 150-ish million tonnes. Agriculture, transport and industry, 80 to 100 million tonnes each in that range. Agriculture, resources and transport industry is about 60 and the built environment's about 30 million tonnes. So that's roughly where it falls. So, and the other piece, whilst the government set a task for 6 sectors, there's a 7th which has to be talked about, and that's land, because the way the national inventory is constructed, land is a sink, and it's a sink for about 80 million tonnes a year of CO2. So you add all those numbers up, you get around about 430 million. That's got to become net zero. Just to touch on some of the highlights for each sector, and clearly in part it's a sequencing problem. And the first part of the sequence is to decarbonise power generation because it flows through into all of the other sectors. So a fairly obvious statement. Some key observations we'd make about that sector is firstly, scale of the challenge. In terms of modelling, and you'll get a range of views, but our view was that demand for electricity will increase 2 or 3 times. So we don't just have to rebuild the current system, we've got to rebuild the current system and then build 2 more. So it's a huge task, it's a huge task. And by the time we do that, we've got to turn around and build it all again because it'll all need replacement. So I think firstly, people have no idea how big the task is. It's an absolutely massive task. So roughly 2 to 3 times expansion in the power system. I'll come back to why some people actually come up with a 4 or 5 times number in a minute. The rate of progress is probably half of what we need to get to net zero, to get to the 42% below 2005 by 2030. So we're not going fast enough from a construction point of view, just sheer development construction point of view. The barriers to that are well known. The less talked about but most critical issue in my view is, or probably a collective view, is that system reliability and security is not well understood, and it's a huge risk. And we are conducting an experiment in Australia moving to very high levels of renewables whilst withdrawing synchronous generation from the system or inertia from the system, which is not a problem most other countries face because they've got nuclear and hydro, a base level of nuclear and hydro in their systems. So there's some hugely challenging technical issues about how you do all that without jeopardising system reliability and security, and that's a task very well suited to engineers at large, but a critically important issue. So what do you take out of that task in energy? It's huge. We're not going fast enough. The reasons why we can talk about later if you want to, but they're pretty well known. And we've got some fundamentally, deeply technical issues to solve around reliability and security in our power systems. Very quickly through the other sectors, agriculture, very difficult to decarbonise. Notwithstanding, we talk about things that might change methane emissions, enteric emissions, it's very difficult. Yeah. Very difficult to have confidence that in the 20s and 30s we'll make significant progress in that area. Transport, half of that roughly light vehicles, so we say technically we know how to solve that problem with electric vehicles, but we don't have the infrastructure to refuel them. So the problem there is not technology, it's infrastructure and refueling infrastructure, and the half of the transport load, if you like, or emissions that are in heavy vehicles. And that's a problem that's not yet really solved, whether it's biofuels, whether it's hydrogen, that half's quite a challenging problem. It's a late 30s, early 40s problem. Industry, and this is the second big call out, the first is the scale of change in power. To decarbonise industry, that part of the thermal load, so if you think about, I'm oversimplifying, but natural gas provides a lot of the thermal energy for the industry sector. That amount of it that's applied to heat, to applications of less than 400 degrees C, you can probably electrify, link back to electricity. But above that, if you're talking 800 to 1,000, you need another thermal fuel. So you need hydrogen, and hence you get the whole hydrogen loop into where the hydrogen can do it. It has to work in a domestic economy, can't decarbonise industry without hydrogen. replacing that fossil fuel bit. Agriculture we've talked about. Resources, the other sector worth commenting on. Fugitive emissions, particularly in coal mining, is a big challenge. Storage of emissions from natural gas production has to be sequestered, so sequestration is a huge issue and a huge challenge. And my final comment is that negative emissions will be big. Even in 2050, there is no way that we can abate ourselves to net zero. It will be abate and offset. And Rose, I'm sure, can talk about some of that, but in the numbers that we've been using, we're relying a lot on you, Rose, to solve that negative emissions issue through things like DAX, towards the end of the 40s, because we cannot get to net zero without very significant change in the landscape, very significant change in the way we farm and use our land, and technology.
Thank you, Grant. Huge structural issues. We'll come back to the resource transition. We had a number of questions about that in particular, but we'll come back to that. Right now, I'd love to go to you, Romilly. I think, Julian, made it very clear what an expert you are on built environment and infrastructure. How are you seeing that particular transition, and what do you see as the priorities in that space?
Sure. Firstly, I do want to call out the IID Industry Advisory Group. There's a number of you here today I'm looking at. So just call out to the colleagues who are involved. Thanks for being here, and we've been having some great fun with you, David, as part of the Industry Advisory Group. Australia is quite unique, and I know that we all get quite, there's a huge focus on decarbonisation and the challenges. But I think we also should reflect on some of the great things that we have already achieved in Australia, and there's hope that when we scale that in the future, the benefits we'll have for that. So I'll just talk about the built environment and infrastructure. Davina is here from the Green Building Council. Australia is leading when it comes to green buildings and sustainable communities in the world, and we have been for over a decade. And you're probably looking at me going, well, she would say that. She's the former CEO of the Green Building Council of Australia. But that's just fact. And there's a reason behind that, and there's an opportunity to do that in infrastructure as well. And the reason being is industry and government over 20 years ago collaborated and created the Green Building Council and created a common metric for how we certify our buildings and our communities. Then when the investor community, being our listed property trusts and their shareholders, started demanding that there was a common way of how we, instead of greenwashing, and how we compared our assets around Australia and globally, what did they have? We already had a very sophisticated rating tool known as Green Star. And when you look at where we are globally, like we did in the Olympics, we really do punch above our weight, and we have for a very long time. So that just shows you that we're in a really great position, because what we're not seeing is, we're not seeing it rural, we're not seeing that in agriculture, we're not seeing it in homes. There's areas and materials, and so we've got a great example of what we can do. Mike Kilburn's here from Infrastructure Sustainability Council of Australia, and so we also have that tool, the IS rating tool in infrastructure. So in Australia, what is great about that is the industry know how to do this. They have been moving in that direction for over 20 years, and there is a common way for doing that. But there's a but. And the but is we're not moving fast enough. Our governments aren't moving fast enough. It's not embedded in our procurement. We have the rail gauge issue of different state governments going, no, I'm going to do our way's better than their way. And ministers saying, well, no, I just care about my state, I don't care about the others. And that has an impact on our industry, and there's a whole lot of a cascading flow-on effect of that. So we have a great example of what can be done and has been done when it comes to the built environment, but infrastructure has a huge impact when it comes to carbon, and we have to move faster, and we have to be able to scale it up. And that's where part of our challenges are in Australia, is where there's inconsistent leadership when it comes to infrastructure. The second thing is infrastructure and built environment go together. And we are starting now to see that collaboration happening. And the great example of that being is the Infrastructure Net Zero project, which there's many of us in the room who are involved in that. It's industry-led along with the federal government and state governments. But we need to move that really quickly, and one of the issues we have around that is capability in Australia, and I think we'll talk about that later on. And we need to scale up really, really quickly our capability in decarbonisation. But the challenge we have is all the other countries are doing that too. So we're competing with other countries, and we don't have enough engineers in Australia, and that's a whole other question you can ask me about in a minute. So I think the challenge we have is we need to move quicker on what we're doing when it comes to the nexus between infrastructure and the built environment, because they both rely on each other. And the other thing I just want to call out, Alison's here from ASBEC, the Australian Sustainable Built Environment Council. There is nothing like it in the world. So many countries have tried to copy what ASBEC is. And the reason I call it out is, again, just to say we are in the right place with the right people, with the right frameworks and the right systems in Australia. But what we've got to do is move faster. So I'll just explain ASBEC for you. All the state governments are involved. All the CEOs of industry bodies are involved. The federal government's involved. It has been around, is it 20 years? 20 years? I should know, I was a former Vice President. So we have the ingredients of greatness. The challenge is we're not scaling up fast enough. And that's why we're really excited, and that we're all the people I've just rattled off there, we're all involved in the Institute, is so that we can use the Institute to try and move faster. Because what we're missing is you've got the government working together and you've got the industry associations together, but we need the private sector, we need the financing, and then we need the industrialised decarbonisation and that research to move much quicker to make sure that we are moving in the right direction.
Yeah. I wanted to add Matt Harding, who's the Chief Engineer of Lend-Lease, who's on our advisory committee as well. And Lend-Lease is really impressive. They're covered under the safeguard measures, but they're also looking at Scope 3, their supply chain issues. And they really want to build sustainable, low-carbon buildings. But the practical challenge is sourcing materials at enough scale. It's the standards. And right now they're importing a lot of their components from other countries. So they, things like smart prefabricated elements in buildings we could be making here is connecting all of that up. So that's a terrific summary.
Can I just jump on that one?
Yes.
I'm on a ministerial advisory group. I don't think you got to that, Julian, because I stopped you. I'm on a ministerial advisory group for a circular economy. And the frustrating thing is in Australia is circularity should just be part of our vernacular. When you look at the Scandi countries, it's kind of like they just do it, and they do it really, really well. And Lend-Lease shouldn't be a lone wolf in this. All construction companies and tier ones, that's how they should be building. And we should be, just knowing that we're looking for sustainable materials, that we're designing and building in a circular manner. And we're only having those conversations now. And the scale of Australia, the size of Australia, but the smallness of our industry holds us back. And then there's a whole issue about regulation. And anyway, we'll just stop there because
we'll go to harmonisation later and computing in harmonisation a bit later. Rose.
And data.
Okay. Rose, you're an absolute leader in Australia and internationally in clean tech. And you're driving masses of hydrogen-related work, but you're also across all of our clean tech work. Can you give a quick summary? I know it's hard to summarise it quickly, but can you just talk a bit about what you're working on, your colleagues are working on?
Thanks, David. First, I'd like to also congratulate you for putting this institute. I think Romilly has already summed it up in terms of the importance of the institute from external. I guess from internal, it is very important to have this platform to bring all those fragmented decarbonisation work, technology and research together. As you mentioned, or Julian mentioned earlier, we got in mining engineering working on decarbonisation, we have chemical engineering, we have electrical engineering also working in decarbonisation in terms of the power. So this is the platform to bring people together. Before I sort of looking at or sum up the clean tech that I'm myself working, I think it is important to sort of know that a lot of the work that we're working in have to be integrated together. Okay, so for example, when we're talking about power or energy, UNSW is famous for the solar panel. So that's the superhero. But the sidekick, like power converter, is also critically important. So how to make sure that the whole value chain is all put together. Yeah. The solar panel require mineral, require metals. The mining, we have mining school that working on that, and critical mineral, how to mining it sustainably, that's very important as well. So the whole value chains, I think we need to really looking at, and I think that this institute should be able to really provide a platform to bring the whole value chains together. I think with the clean tech, because I was just talking to someone that when I was a student 40 years ago as a chemical engineer, as Julian said, we're looking at oil and gas companies is a place that we're going to afterwards, but now changing. And we're looking at now people talking about electrification. So we're going to have a lot of clean energy, clean power, clean electrons. How we're going to use it. And that clean electricity is the one that we're going to actually transform a lot of industry. According to the International Energy Agency roadmap, net zero roadmap, saying that most of the technology to meet the 2030 targets, we have that because we got as Grant also mentioned, the technology is there. The issues is about scaling up the policies and so on. But to meet the net zero target for 2050, that's still a lot of the technology is still not up there. We need to really develop the technologies in terms of looking at how we can solve those problems. So some of the work that we're doing in the university is looking at, we call it the power to X, looking at using the renewable power to make X. And Grant mentioned about hydrogen. So hydrogen is very important. Currently, 100 million tons of hydrogen is produced by fossil fuels. So using the clean energy, we can really replace that 100 million tons because that 100 million tons associated to 900 million tons of CO2 that's emitted. So we can solve that decarbonization of producing the hydrogen itself. And hydrogen is a molecules that make a lot of different chemicals as well. For example, ammonia, you're talking about agriculture. And so we need to decarbonize those industries as well. And a number of years ago, we got funding from DFAT to looking at exporting green hydrogen to Germany. And that's called the High Supply Project. And when we started, we're looking at exporting hydrogen as a hydrogen molecules to Germany, which is very far away. And to transport that, you need to liquefy it. You need a lot of energy in order to be able to liquefy that. So we know that that's not feasible, right? So we need to really think about what other things that we can actually produce in Australia and what sort of investment we need to put in the industry. So there's a lot of discussion. Even from that time, we sort of say that perhaps that we're looking at, instead of we export iron ore and we export hydrogen separately, why don't we produce a DRI or metal iron that we can then export it, transport it much more cost effectively rather than liquefy that. So those are the things that now we are looking at in terms of hydrogen exporting rather than as a product, value-added products, rather than just as a molecules as well.
That's a great example of a journey to closing in on what is going to be competitive and realistic. I mean, you started off with hydrogen as an export product, liquefied, which requires really complex infrastructure, and now you're zeroing in on ways to use hydrogen to make fertilizer, to reduce metallic ores, putting those together to create new value-added products. But how long did that took years? How can we accelerate that process to more rapidly close in on what are going to be viable technologies? We've had a lot of questions about where we should be focusing technologically and how do we accelerate the process. Now, what's your perspective on that?
So there are sort of technologies available already, like for example, making ammonia using the hydrogen, right? Because you can still using the existing technology. The only problem is that you cannot just plug and play hydrogen that coming out from the electrolyzer into the integration of the system. So in terms of to accelerate it, it's important, to work together with the industry to looking at what are the challenges. Because the process that you in the lab that you develop the technologies is you cannot really adapt it straight away. And therefore, those kind of interactions between the industry directly to know what are the challenges that they have there in order to be able to modify that.
Just quickly, so a factory for producing or for smelting iron or another metallic ore is completely different to the conventional technology. You have to start from scratch. Yep. It's a greenfield site. Mm-hmm. That's a lot of money. It's a lot of infrastructure. Grant, what's your views on that? How quickly do you think it would take Australia to, let's say, build some new iron foundries or copper smelting works?
So I might start answering it in a slightly different place.
Okay, I'm sure. I thought you might do that.
Because you did, and Rose also, you introduced a very important dimension, which is time.
Yes.
And in Australia, the overlapping of the safeguard mechanism with what one broadly thinks of as industry decarbonization, it's almost one-on-one, right? And that's a 2030 target, right? So something like 30% reduction in emissions from those safeguard industries by 2030. Yep. As many of you would know, you don't incrementally reduce emissions in steel making by a few percent a year. It really requires a total re-engineering of those businesses. So I want to add one more bit of detail before fleshing your answer out. That safeguard mechanism is a mandatory mechanism. It requires 4.9% a year reduction in carbon emissions for safeguard liable entities. That will break most of the export competing industries. They won't exist, in my opinion. But they will also opt for what's called the trade exposed baseline adjustment mechanism, and that will come back to maybe a 1% adjustment, and that means they will probably have a slightly longer runway. But the fundamental, I think, answer to your question is that it will require fundamentally new production processes in cement, steel, fertiliser production. It won't be incrementing current production technologies. And the fundamental trade-off is whether we end up importing those goods or not. Do we import clinker from other jurisdictions?
Yeah.
You know, these are the economic and real world competitive issues that Australia faces.
That's the kind of step change shock I was referring to in my talk. I mean, a perverse outcome of a safeguard measures would be to actually close current
Well, we don't want to
manufacturing and
deindustrialise our way to carbon.
That's the easiest way to meet your target, though, isn't it? It's to shut down the steelworks. Yeah. We don't want that, do we? So how can the government support a smoother transition when there's not much certainty around this kind of investment?
Yeah. So, well, the government's established quite a few pots of money to help those transitions. Accessing, certainly one of the common criticisms I hear is difficulty in accessing those pots of money to help industries make those transition. And again, I'm putting this in a 5-year context. 2030 is barely 5 years away. So we're talking about major transition in productive processes in Australia in 5 years. I should digress again. You can meet your safeguard liability by offsetting with ACCUs, but most in the carbon business don't believe that's the way we should get there, because those offset mechanisms will be needed for agriculture, because agriculture in turn has difficulty decarbonising the agricultural process. Yeah. So you do want fundamental change in technology. Government is trying to facilitate through a whole variety of funds, question mark how effective are those policies being implemented and how accessible is that money. The second point, and perhaps final point, David, is, for example, in this forum and to the university and to you and your decarbonization, you haven't got 10 or 15 years to do this. You've got to kind of pull the finger out and get on with it, like right now.
And meanwhile, the rest of the planet is changing around us, and the market access issues are changing.
And the key thing is that the technologies you talk about don't need to be available ex-university prototype. They need to be in the hands of civil contractors who will write 30-year construction and guarantees and performance guarantees. That's a long journey to get technology to that point. So it is a right now, let's get on with it issue. It's not a 10, 15-year burn rate here.
Romilly, engineers are in the hot seat for this. They're the ones who are being asked by their CEOs and their financial controllers, what technology should I invest in? What are the risks? How long is it going to take to get this lab tech actually certifiable, robust enough to work? What's your view on this?
I think we have some challenges in Australia. We don't have enough engineers. We
ship them out overseas.
Well, not even that. We don't grow them in Australia. Okay. So our homegrown pipeline of engineers is declining year on year. I'm just giving you the facts. 62% of our engineers are born overseas. We're very reliant on overseas qualified engineers, and we love and welcome them because that's we need them. So just. I'll just go to the capacity issue we have, and then I'll answer your question. When you look at countries that we're competing with, whether that's India, Germany or Denmark, they don't have a problem when it comes to engineers. It's like held in high regard, held, high profile. Engineers are just seen as, on the level of doctors, really, really high regard. And not only that, their gender equity is really high as well, like between 35 and 50%. In Australia, it's 16%. And only 19% of students, female students. So we're missing out on half our population. So we have this massive challenge that we have to decarbonise. Who do we need? We need engineers. And our pipeline is broken. So it's broken from our schools. We're not doing compulsory maths and science. And Australian kids are choosing other courses, and those that are doing engineering, a lot of them then aren't finishing in engineering, or when they complete their degree are moving into other industries. So I'm going to be really blunt. We need to make sure that our kids go to uni, do engineering, and it's free, and they don't have a HEC debt, because that's what they do in Denmark.
Right.
It's a 5-year degree, it's free, and they're paid to go to university. And their last 2 years, which is going to hit onto some things that Grant's interested in, they have to work in industry on real world problems. So they're pragmatic and practical engineers who have not spent 5 years at uni, they've spent 3 years at uni, and then 2 years on the ground, hit the ground running into internships, cadetships, so on and so forth, and they don't have a HEC debt. So I'm just being really, everyone laughs, I know you do, but I'm being really serious. If we need more engineers and scientists in Australia, we're going to have to pull the wallet out and pay for them to stay at our universities and complete it. And we shouldn't shy away from that, because coming back to, we have the skills in Australia. I have met the most amazing engineering researchers around Australia who do remarkable things, but they need the backing of engineers coming through who are then going to be able to implement it, who are then going to be able to execute it and plan it. And there's some of the challenges we have. So we do have the engineers, but we have limited amount of engineers. And then the final thing I'd say is we also need to make sure our engineers have broad range of skills, that they understand the use of AI, that they're digitally literate, and they know the opportunities in the future. So there's a lot that we're doing. We're working closely. I work closely with Consult Australia, Jonathan's here now, on what we need to do with engineers, but we're just desperate for thousands of more engineers.
Well, bringing it back to economics and green industry development, one of the reasons kids don't want to do engineering is that they're not seeing those really interesting jobs, that they're not seeing that pathway. But if we can create green industry, well, then it creates that pull-through, does it not?
Well, the younger generation want to be, they're very purpose-driven.
Yeah.
They're really keen to work in that environment, but we do have a brand issue, and we at Engineers Australia are trying to work on that, but we can't do it alone. But we do have you see kids going into trades, which we need, so I'm not in any way, but they go into trades and they can see an end in sight with trades, but with engineering, most kids don't know what engineering is. Especially young women, they see it as hard hat and high vis vests, and it's not. There's so many fascinating roles in engineering.
Yeah, but name's a bit of a problem. It's not about engines anymore, really, is it? But I digress. This isn't a meeting about repitching.
So just quickly on engineering and how we're going to get there. We're going to get there through micro-credentialing. We're going to get there through cadetships. We're going to get there through working closely with the universities, which we're doing. And we will get there through research and all that. You look at the fantastic research we're doing around Australia. So we will get there, and we have amazing minds in engineering around Australia, but we just need more engineers.
I'm going to bring it back to economics and the resource sector. And Australia exports, I think it's $297 billion worth of energy resources in 2023. That's a big amount of money to replace in the economy. And also, if Australia wants to make a contribution to global warming, right now we're offshoring the pollution from those resources. Realistically, how can Australia phase out those exports and replace them with alternative sources of revenue within the economy? And to me, that's always the elephant in the room around this. Grant, what are your thoughts on that?
Well, that's a non-trivial problem.
Somewhat.
And if we sort of broke it down into bits, which of course is the best way to deal with it, if we think about iron ore as an export industry, we talk about potential other steel making or iron making processes. I'll come back to that in a minute with an example. You've got coal and you've got natural gas. I mean, they're your three largest resource-based exports. Steaming coal, clearly you'd expect steaming coal to fall, and certainly for domestic production, we don't expect to have a coal-fired generation sector certainly in 10 years.
Yeah.
But met coal, until new steel-making processes develop, you've still got met coal.
Yeah.
And methane emissions from coal mining is one of the major sources of methane, and many would argue underestimated in the national inventory. A lot of issues around methane measurement. In respect of the LNG industry, of course, the East Coast LNG industry doesn't produce CO2 in the production process because there's no CO2 in the gas, but in the West there is large amounts. Chevron's or Gorgon's an example. That can be sequestered. It will have to be sequestered if that industry is to continue on a low, little own zero carbon basis, but that's possible, that sequestration. And iron ore, going back to, that's a fundamental shift in technology and in production. So the other side of it is, can other forms of what people refer to as green minerals provide the offset? I've not seen compelling numbers that show that the scale of that opportunity is the scale of the challenge. I just haven't seen that data. I've seen a lot of hope, but not that data. And of course, there's a commercial overlay. And this is a substantial issue in a lot of these policies. And what makes it difficult is that commercial overlay that's premised around whether the world progresses uniformly on this task or differentially. And a classic example of that would be our nickel industry at the moment. We're in grave danger of losing our nickel industry because other countries have seen it as a source of competitive advantage, and other consumers of Australian products have seen it in their interest to stimulate production in other jurisdictions in Australia. So there's some quite complex commercial issues in saying that we can directly substitute lost export opportunities for new ones. But the magic of economic modelling is that something else in the economy steps up and does the heavy lifting. It may well be university students if our good colleagues can convince the government to not put caps on university students. And clearly there are other sectors of the economy that can step up.
But it's time as well. So if we look at critical minerals, if we're looking at replacing in the mining sector, we're not moving fast enough. Like, because realistically, if you want to you're going to have all the infrastructure around it, the processing, and all the other elements around it. We need to be moving faster in some of those areas. And I'll let you talk about hydrogen. You're much more of an expert than I am. But, there are opportunities in other green industries. But we've just got to make sure that we have complementary regulatory environment, not an adversarial regulatory environment, which means in the end everyone just goes, that's just too hard, I'm not going to do it.
No, you've got to start somewhere.
Yeah. So, David, can I just add
please,
one thing?
Rose.
Yeah. So back in 2017, when we're trying to lobby the government to develop the National Hydrogen Roadmap, that was the argument we used. If we're not going to be able to export LNG anymore, because Japan doesn't want to import our LNG, what can we export? So that's the reasons that we're looking at the roadmap of the hydrogens and how we can make the hydrogen using renewable power, which Alan Finkel using as the shipping sunshines out there. And that time, the view is that we can still export that because we can liquefy that. But I think the more we study it, we can't. So that's why we need to look at the replacement. I think Grant mentioned about the iron ore and also the mineral. I think we need to really making it not just dig from the ground and just export it out. We need to make it added value. So we're talking about lithium. We've got a lot of lithium reserve, right? We can really making it as more value added, as a battery. We got cobalt reserve. We got a lot of other critical minerals that we can really sell as well.
It's a portfolio of economic solutions. I wish Richard was here because he's got a great macroeconomic view of how this all works. But ultimately, you can't replace one commodity with another. You've actually got to value add what we do. We make more money out of what we create before we export it. And that involves...
Well, future made in Australia, and that's
essentially what it is.
Yeah.
But it's zeroing in on what is actually going to be competitive, and that's where the timing issues become so critical. We had some great questions about carbon border control mechanisms, and whether we need policy that protects our green industry as it emerges. And I think it'd be great to talk about that. I mean, if we're going to get green industry and we're going to accelerate it, we probably do need some policy levers in the mix to drive that. What are your thoughts? Well, Rose, do you think that carbon border control mechanisms would help with hydrogen? I mean, for homegrown usage of hydrogen?
Well, definitely, you have to have the right policies. I know EU looking at carbon tariff, right?
Yeah.
So looking at the stick method, and US looking at the IRA, which is more incentive methods. And I guess that in Australia, we need to looking at what is the sort of our case, I would say for both of them, you need to give incentive in terms of to really drive that investment more. And at the same time, you probably also need to have some sort of carbon tariffs and things for some of those, so that you can really have more of the green industry to grow. So I would say that in Australia, you probably need to have policies that have both of them, which is both the carrot and the stick.
So we need to protect our industries, Grant?
Well, the government's commissioned a study on that. Frank Yotso from ANU is doing that study. He's pretty close to delivering his final report, and it would be wrong to preempt that. I've seen that study. It will bring the question that we are fundamentally an export-oriented economy, so how are we going to get in our head barriers? That's the first point. The second point is that in the domestic economy, and here's probably the difficult economic point to understand, it doesn't matter what hydrogen costs. If we have to use hydrogen to substitute for high temperature applications in industry, we will use hydrogen. What you do is solve for price. The price will be high. And the modelling I've seen, and when you look at the cost of abatement towards 2050, it's a big number, right? But the economy will do that in order to achieve that decarbonisation goal. But what it means is we won't necessarily be competitive for exports. So we don't need to protect the domestic economy. The economy will adjust.
Which brings it back to balance of trade. So if you start generating critical materials here in Australia, there's less need to import them. And is the government seeing that as an important part of the equation?
There is clearly a suggestion that we can produce a lot more, for example, green steel, for lack of a better term. But you've got to kind of get your head around the fact that in order to do that, we need open contestable markets in other jurisdictions. So how will Australia, which has traditionally had a very open, probably one of the most open border policies to trade, square that equation a great way?
It might be time to change that.
Yeah, so you asked the question earlier, what will substitute for our fossil fuel and minerals exports? Putting tariffs on any imports to protect a small industry when we're chasing a big industry for exports, that's going to take a bit of policy thinking.
It is. It's interesting we're seeing green trade alliances forming around ASEAN. We've got a very interesting one with Singapore, Australia has right now. Romilly, is Engineers Australia really reaching out to other jurisdictions in ASEAN and really thinking about how to build green industry in cooperative ways with other countries in our region?
We're not as Engineers Australia, but I do know that Nicholas Moore, former head of Macquarie Bank, was the lead on a ASEAN report that came out late last year, early this year, and said the opportunities within our region are huge. We all should be playing to our strengths and working collaboratively on the opportunities in where we're going in the future when it comes to green industry. So it's worthwhile looking at that report and the opportunities around it.
Yeah, because Australia doesn't have to make everything, but there are complementary relationships with our allies.
Yeah.
Dave, I think to take that point and go back to the earlier point, we need to accept that things might turn out completely differently. So, if we go back to the early days of hydrogen, some might forget that a lot of that work was actually driven from converting brown coal into Victoria, into hydrogen, and that's where the whole hydrogen thing began, was actually exporting energy from brown coal, premised on high demand in Japan. But that's not what I've seen in Japan. There's a very interesting map that some have seen, which is a map that shows the source of every possible sequestration by distance from Tokyo. Right, so it is very possible that we continue to export energy in the form we do, but we might have to accept CO2 in return. And so we end up having a carbon sequestration industry that's much bigger than anybody's envisaged. The use of landscape may be much greater if we talk about international trading of credits, ITMOs and the like. So we have to hold ourselves open to there being different solutions that might not even be necessarily popular, but nonetheless may well turn out to be the most economic choice.
Well, funnily enough, that is the key to university-based technological research. It's just thinking right outside the box and looking for things that nobody's thought of before, right? And we probably need to do that when we look at our economy as well. But we need to speed up the whole process. I mean, how do you get the right people around the table to advance these challenges? There's a lot of, we're going around in circles in Australia.
I think just if I could have a go at making an observation there. There's several really key questions in this whole debate. And one of them is the question of voluntary versus mandatory.
Yes.
Now, one of the big issues is how do you speed things up? And the answer is the lack of a revenue model, or the problem is the lack of a revenue model. The investment is not flowing because no one knows from where comes the revenue to underwrite that investment. The answer is government. But government can't solve it. It doesn't have enough money, right? Can't solve everything. One way of solving the revenue model is there is more mandatory in the scheme. So, for example, you asked Romilly about building. Most of the technology solutions are there for the building sector. They could be put in place through building regulations and codes that require them.
Or procurement
to
policies
quickly.
and stuff like that.
If that happens, there's no revenue problem, but they are mandatory. And you've got to be willing to have that discussion with the community. Do we mandate that all export projects have to sequester their CO2? My view is you have to. Do you look at very challenging policies and say, why are we using our natural gas for space heating when there's perfectly good electrical alternatives in heat pumps and the like? So, what are we going to do about our gas distribution industry? There are some very interesting and challenging questions. And the other one, of course, which was difficult for government to get through, was mandatory fuel standards.
Doing what, sir?
Mandatory fuel standards. So the two biggest single pieces of mandatory policy in Australia is a safeguard mechanism and mandatory fuel standards, which will drive change. Because they're mandatory, they will bring revenue, people will invest, but a lot of our architecture is still voluntary, and that is a fundamentally key policy point that the community...
Well, that's the crux of many questions, by the way. I mean, the safeguard measures right now only cover 215 facilities, and some people have asked, well, should it be extended? And some people have said, no, it shouldn't, because of the complexities around baselines and the shocks that you could create to the system, even greater than the shocks, but are potentially greater by the safeguard measures as they stand. So there are limits to what you can do with mandates. Well, for a start, do you think the safeguard mechanism is effective? Is it taking us where we want to go?
I think the question is, so the safeguard mechanism is a fact,
Yes.
and so my slightly just technical answer to this is that I believe all of the trade exposed sectors will go for the 1%, and they will probably offset in order to get through the next few years, right?
Yep.
But what most people don't realise is the extent that they don't go the 4.9 and they go the 1.2 or whatever the number is, has to be made up by all the other companies. So there's an absolute cap on safeguard which must be met, right?
Yep.
So to the extent trade exposed doesn't meet it, other domestic industries will have to pick up the difference, and this is not well understood. So it increases the challenge in other areas. Will it be effective? It's a fact, it's got to happen. Will it have consequences in other areas?
And we've got some very high-end consulting firms in the room who I'm sure are all over this. I mean, for putting all this together is pretty tricky, and we don't want to break the economy. Do you feel that we are moving quickly enough with the mix of policy measures, and are we agile enough in adapting them?
Well, we're not moving quick. So if one places achieve, well, so one other point. We all know net zero by 2050. Everybody can repeat that. My question to the group is how many tonnes in the carbon budget between now and 2050? Does anybody know that number?
No.
4.5 billion tonnes between 2021 and 2030. So to meet our 43% below by 2030, we also have to limit ourselves to 4.5 billion tonnes of carbon through that period. That's becoming the controlling constraint. That's why we have to act quickly, because it's the actual carbon in the atmosphere that causes the problem.
But what worries me is we get to 2030 when the tougher measures kick in, all of them, and companies haven't made the investments now in order to get to that target, then the easiest response would be just to switch off.
That's
and increase imports.
Yeah, that's a real risk. Yeah.
How risky do you think is the likelihood of that happening?
I'm not that concerned for trade exposed, because I think they'll go for what I call the 1%, but the lower number, and they'll use offsets. But that will get us through to, say, 2030. So I'd say we've got a 5-year time frame to figure out the technology and the investment models that allow fundamental change in productive processes in Australia.
Okay.
So I think we've got between now and 2030 to figure that out, but we haven't got between now and 2040 to figure it out.
Okay.
We will lose those industries if we don't find solutions for them in this 5-year period, where we're at significant risk of losing those industries. Yeah.
I'm conscious of time. I
Yes.
think we're about to go red. We did.
Well, I was about
So
to.
I think the thing is, we've done it before. You can see green shoots around Australia in a number of areas, and the economy is going to make a play in this, and it comes back to financing. And so, I feel positive that it will be a challenge, but we will get there, and that we have the right people. But I do feel that the governments have got to be more open-minded and agile and supportive with both industry and academia to create a positive environment for us to do it. Because we've got examples all around Australia of some, great projects that we've done and, R&D and innovation. But they've just got to let us get on and do it.
Yeah, but Will said, look, it'd be remiss not to raised the question of nuclear. We've had a number of questions about that. So I'll open that one up to the panel. Do you think nuclear has a place in the energy mix for Australia? Or under what conditions might it have a place?
Have a go at that, Rose?
I'm going to start with Romilly. I'm going to ask Romilly.
I think time is against us on nuclear because we don't have a nuclear market in Australia when you compare other countries. Throw AUKUS in and we're throwing, when you think about what we're trying to do on nuclear, we're throwing, which is defence nuclear, we're spending a lot, we're trying to get people up to speed on nuclear in AUKUS. If we've got to meet our 2030 and our 2050 target and we want a clean, safe and reliable technology, I think nuclear is probably in the mix. There's more work that needs to be done in it, and I'm not sure we have the time to do that. I think we're on a path at the moment in a number of areas like renewables and many others and green energy. And I personally, this is not with my EA hat on, but personally, I think it will divert our attention if we look at that now because we've got too much we've got to do too quickly.
Yeah. Look, I don't want to verbal Richard because he's not here, but what he told me was that irrespective of the nature of a technology and the stage of the smaller reactors in terms of development, we're already committed to renewables. In an economic sense, we're already well down that path, and it would just be perverse to try and step away from it. That's what he said to me. Grant, do you have any views on this?
Well, nuclear won't solve the carbon budget problem, right?
Yeah,
so
okay.
That's why it just won't solve that short to medium term issue. But the other thing you've got to factor in is we don't need to replace the current power system with renewables. We need to build 3 power systems, right? Maybe 4 or 5. We need everything. We need absolutely everything. And in order to preserve system security and reliability, we need inertia.
Well, to be frank, that's what China's done. I mean, they're building nuclear power stations, solar stations, hydroelectric, you name it, at a rate of knots.
Yeah. So everything has to be on the table in the long run, but it does not solve the budget problem in the short term. So.
Okay.
I see nuclear is probably the long-term problem, long-term solution, maybe 2045, but not now. Now we got a lot of the renewable, and I think one of the things is that Australia is blessed with the renewable resources. Country like France or other countries that do not have renewable resources, then they need to go to nuclear or other.
I haven't seen that much in the public discourse, but we have the sunshine that those coal countries don't. So it's not a level playing field. We've got 2 minutes left to solve all the world's problems.
One thing that we didn't really talk about is social license and impact that much. I think it's very critical. And I think we're talking about the technology policies, but I think that it's really important to bring the society in with whatever new technology. There's a mindset that, I don't want the transmission line on my backyard, and how to really, really educate and bring them as a sort of ownerships and also responsibility. Inclusiveness, I think it is very important from the start. Even the hydrogen project, for the society to really understand that, to accept it, because I think that that's a very critical thing, and maybe media can play a role as well.
Yeah, it can. And by the way, I mean, we're doing NIMBY on a national scale, just like every Western country. We've offshored the negative consequences of industrialisation. The 8 billion people on the planet aren't going to let us keep getting away with that. So we have to change it as society globally, and Australia can lead. On that note, thank you so much. I know you're all thinking away like crazy, and we probably haven't covered the territory at all, really, as you would like, but we can now talk about it outside over a drink. So thank you very much.
It's been an exciting discussion. Please join me again in thanking our wonderful panel this evening. And very briefly, I just want to thank you all for being a part of the Institute launch. It's pretty clear the work that we have ahead of us is going to need a lot of skilled people. Jobs in decarbonisation are interesting, they're well paid, they have terrific employability prospects, they directly address one of the biggest challenges of our time. So please share the insights from tonight with anyone who will listen to them, anyone who's thinking about their future career, including young people, of course. UNSW has programs in all kinds of disciplines to prepare for decarbonisation careers. Look, the Institute for Industrial Decarbonisation is really looking forward to working together with you if we're not already. If you are already partnered with us, then please do think and do consider who among your partners might benefit from joining us too. And with that, thank you, and I hope you enjoy your evening.